Hi, it's Mrs. Scarple, and in this video I'm going to walk you through finding the missing side of a right triangle using trig ratios. Before we get to that though, I need to show you how to use the calculator to find the sine, the cosine, and the tangent of a specific angle measurement. What you've been exposed to so far is finding the ratios of different angles in a right triangle, but not for their angle measures. So we're going to be using the TI-84 calculators, and the first thing you want to check is if the mode of the calculator is in degree mode, because our angle measures are going to be given in degrees. The mode button is the second button on the first row, not the very top row, but the first row next to your arrow buttons. It says mode on it. So we press that button, and you'll see the word degree in the third row of that window. So you need to press your down arrow button to the third row and arrow to the right so that it's flashing on degree, and press enter. And now you should just have degree highlighted and flashing. And then you can clear to go back to your original window. To find sine, cosine, or tangent of any angle once you have your calculator in degree mode is as simple as using the sine, cosine, and tangent buttons, which are two rows above your number buttons. So if I want sine of 35 degrees, I press sine 35 and enter. And our directions said round to the nearest thousandth. That's the third decimal place. It goes tenths, hundredths, thousandths. So we're going to round to this third place, and since the 3 is followed by a 5, this is going to round up. So we're going to have 0.574. So 0.574 is going to be our approximation for sine of 34 degrees. For cosine, it's going to be cosine 35, enter, to 3 decimal places. The 9 is followed by a 1, so that's going to stay 9, so 0.819. And then for tangent of 35 degrees, we press tangent 35. And we have 0.700, and that last 0 is followed by a 2. And I am going to write this out to the 2 zeros because this is a decimal that does go on much further than just those 2 zeros. If I leave it at just 0.7, then I'm implying that it just stops at 0.7, and it doesn't. So I am going to write this as 0.700 to show that this is in fact rounded out to 3 places and isn't exactly 0.7. So let's just quickly do these next 3. I'm going to clear my window. Sine 56. .829, cosine 56, 0.559, and then we have tangent 56. 1.48, this 2 will actually round to 3, so 1.483. So when you're using any scientific calculator, you want to make sure that calculator is in degree mode before you find the sine, cosine, or tangent of any angle measure. So, how does this work when solving for a missing side. Here the directions say write a trig ratio for the given angle with the given side lengths. Then use it to find the length of the indicated side. Round to the nearest tenth. So I'm going to do just like I did when I was just finding the ratios. I'm going to circle the angle that I'm given. In this case it's the 65 degrees. I'm going to identify my hypotenuse. Remember, the hypotenuse is directly across from the right angle. I'm going to identify the side that is across from my given angle. That's my opposite. And that leaves the remaining side to be my adjacent. And I always get in the habit of marking all three sides. I'm also going to take the time to remind myself what my ratios are. We have sine, which uses the opposite over the hypotenuse. We have cosine, which uses the adjacent over the hypotenuse. And we have tangent, which uses the opposite over the adjacent. If I look at this triangle, I know the hypotenuse, so that means I'm going to use either sine or cosine. I know the hypotenuse, I'm looking for the opposite. So if I want to know which of these I'm going to use, I'm looking for the opposite and I know the hypotenuse. That's going to be sine because that uses the opposite and the hypotenuse. So I'm going to write this relationship, that sine of 65 degrees. Before you would say sine of A or sine of B or sine of C or something like that. But in this case it's going to be sine of 65 degrees and we're going to write a ratio. Sine of 65 equals the opposite, which is the B, over the hypotenuse, which is 17. So now I need to solve for B. I need to undo this division. Well, to undo the division, I need to multiply. So this 17 cancels out. And in my calculator, I'm going to enter 17 times sine of 65 degrees. Now I'm not actually going to enter that degree symbol because my calculator is already set to degrees. So I get my calculator, clear my window, and I enter it just like it's written. 17 times sine 65. Enter. And the directions said round to the nearest tenth, so that's 1 decimal place. So we have 15.4 is the approximation for B. So this side over here, this opposite side to my angle, is approximately 15.4. Let's take a look at another triangle. We're going to solve for C. And again, we're going to round to the nearest tenth. So let's first identify what we have. We have our given angle. We know which side is the hypotenuse. We know that the side across from the given angle is the opposite, and that leaves the remaining side to be the adjacent. It doesn't hurt to write the SOHCAHTOA or have it on a piece of paper near you every time you're doing one of these problems so that you can see we're looking for the hypotenuse, that's the C, and we have the adjacent. So we have A and we're looking for H. The ratio that uses A and H is cosine. this is the one we want to use. So we look at what we have, and that's how we determine which ratio we're going to use. So we have cosine of 70 degrees equals, the adjacent is 36, over c. Now this is different from the last problem because our unknown is in the denominator. So what I'm going to do is I'm going to write the cosine 70 over 1 so that it looks like I have a proportion. And then I'm going to use the butterfly method to solve this. So we're going to end up with c times cosine of 70 equals 36. Now if I want to get the c by itself, this is c times, to undo a multiplication you have to divide. So we're going to divide by cosine of 70, and to find c, we're going to enter in the calculator 36 divided by cosine of 70. So we'll take our calculator, I'm going to clear the screen, 36 divided by cosine of 70. Enter. To one decimal place, that 2 is followed by a 5, it's going to be 105.3. So c is going to equal 105.3. And one last one. Find the length of YZ. So I'm going to call that X. Round decimal answers to the nearest tenth. So we're given the 52 degrees, and we know that across from the 52 degrees is going to be our opposite. We know that across from the right angle is the hypotenuse, and that leaves the remaining side to be the adjacent. So we're looking for the opposite. We know the adjacent. If we remind ourselves of SOHCAHTOA, we will see that the ratio we want is tangent, because we're looking for the opposite and we know the adjacent. So tangent of 52 degrees equals x over 8.5. And just like the last one where I wrote it as a proportion, I can do the same here. And what you're going to find when you use the butterfly method is I'm going to end up with just multiplying 8.5 times the tangent of 52 degrees. Because 1 times x is just x. So we take that calculator, I'm going to clear it, 8.5, and I could just use the parentheses like I did on my paper here. Tangent 52, I am going to need to close my parentheses, so that closes the angle, and then that closes the times tangent. And to one decimal place, the 8 is followed by a 7, so it becomes 10.9. And that is how we use our trig ratios to solve for a missing side.